Okay, exercise 13 in two parts. Kadir is basting a roast turkey with a meat baster that creates a pressure of 99,800 pascals when the plastic bulb is squeezed and then released. If turkey juice rises 0.09 meters, 9 centimeters, up the tube of the baster, what is the density of the juice? Now, so what do I mean by that? Well, if you know what a turkey baster is, if I press the bulb of the baster, a turkey baster is a long tube, kind of shaped like a syringe, but with a bulb on top. Big. And you depress the bulb, right? And then you release it. And normally, you press it, release it, press it, release it. Air comes in and out, in and out, in and out. However, if I depress it, think of sort of Newton's third laws, action, reaction. If I press it, and then I put it into the fluid's going to rush in. The bulb is going to expand and draw that pressure and draw the water in. If I depress it with a certain amount of pressure, it's going to rush in because of that pressure, but also because of the atmospheric pressure. So the atmospheric pressure is driving the water into the baster, as well as the pressure from releasing the bulb. Pressure, release pressure. Newton's third law, right? I depress the bulb with a certain amount of pressure. The bulb applies a pressure to my fingers. Release it, I do the opposite. So this is sort of like hydrostatic pressure in a sense, but we're talking about the air pressure and the baster pressure. The air pressure and the baster pressure. Because when I depress the bulb on the baster and I release it, you understand where the pressure is coming from that's drawing the fluid up. The baster. If the doctor has a syringe and he's putting medicine into a syringe by depressing, by expanding the cylinder, the piston in the syringe, that is allowing fluid to be drawn into the cylinder, but also the atmospheric pressure is causing that to go in too. So it's not only the pressure from the bulb expanding that's drawing the fluid into the syringe, the baster, it's also the atmospheric pressure. So the difference in pressure, the pressure differential, is going to be P sub A minus P sub B. The atmospheric pressure minus the baster pressure is going to be the pressure differential. So the density of the juice is going to be the atmospheric pressure minus the pressure created by the baster divided by GH. Try to do that. Here's the baster pressure. Here's the atmospheric pressure. Okay? Try to plug in, see how you can do, okay? Take a look at that. That's the general equation. This is what we kind of changed it. This is the new equation. Here's your data. Plug in. H is 0.09 meters and G is 10. All right? See if you can do it. See what you come up with.